matched filter. So this we'll see in terms of baseband communication. Baseband communication, that means communication without modulation. Okay, this is the communication or transmission of signal without modulation. That is the concept of baseband communication. That means communicating with the nearby equipments, with the nearby device. Whenever the signal wants to go for longer distance, there is no other way to go. Only we have to use modulation, or otherwise we have to use a physical medium like wire. But whenever we are communicating with a long distance without modulation, maybe we may be communicating with the help of wires. Then that kind of communication we will call it as a baseband communication. So you should know the difference between baseband and passband. Baseband means without modulation. Passband means with modulation. Passband means with modulation. So mostly you can compare this kind of communication with the computer communication. Say for example, how the keyboard is communicating with the CPU, how the mouse is communicating with the CPU, or how that RS-232 port is communicating with CPU. So these are all comes under the baseband communication. So now I am in the baseband communication. See, mostly in terms of computers, whenever we are communicating, mostly the signal is digital signal, ones and zeros. The same signal we will represent in terms of digital patterns, digital waveforms. Okay, like a square waveforms, continuously varying square waveforms. So here for matched filter discussion, we will take some simple rectangular signal. I am having this signal, say 0, it is having 0 to t time duration, 0 to t time duration with amplitude of a. So now I want to transmit this waveform from one place to another without any modulation through wire. Now what is the major problem here in general? Okay, if you want to transmit through some medium, okay, either it may be the wire, but again here some noise will add in the channel, okay, along with the signal. This is the original signal, so some noise may be picked up in between. Then at the receiver side, instead of this way, the signal may get the shape of the function may get disturbed like this. Okay, now we know that suppose if it is a, again I will use the decision device. Okay, that decision device like with respect to a by 2. Okay, because average value is a by 2. Suppose if the received signal is greater than a by 2, then I will do in favor of a. If it is less than a by 2, then I will do in favor of 0. Again, the major problem here is where I will be taking the samples, either here, or sometime it may go to negative also. Suppose if I am taking the samples, observing the samples here, exactly I will get the opposite answer. Exactly I will get the opposite answer. That is the major problem in the reception of the baseband communication. So now to overcome this problem, okay, we will be using matched filter. Okay, directly we cannot do the sampling. So to overcome this problem, we will be using the matched filter at the receiver side. So why we are using matched filter? Our main aim is to detect what is the original signal transmitted. Even though there is noise in the system, okay, even though there is some disturbance in the system, how to recover back our original signal. That is the concept of matched filter. So now I'm having signal, same signal, say x of t with the duration t and then a amplitude. So this system is passed through channel, then definitely now I am at the receiver side. Okay. Now at the receiver side, we will be using some filter, say matched filter. Now, what is the function of matched filter? Say h of t, matched filter impulse response is h of t. Then this is the output of the impulse response. So now the incoming signal will be passed through the matched filter. Okay. Now, what should be the response, impulse response of the matched filter with respect to the signal? Say the signal is x of t. This signal is x of t. So now, if h of t is equal to x star of capital T minus t. Okay, suppose if you design a system, okay, h of t with this kind of functionality, then very easily you can recover back your output very easily. Even though there is noise in the system, very easily you can recover back your output. So now how? Say that output, I will call it as y of t. Y of t has to be exactly same as x of t. Then we know from the basics y of t is x of t convolution with h of t, convolution with h of t, that is x of t convolution with x star of t minus t. Again, star is for generally for complex signal. If it is real signal, we no need to worry about that complex sign. But again, after avoiding this complex sign, you have to calculate what is x of capital T minus t. Again, this is the basics of signal system. In a x of t, now you have to identify what is x of capital T minus t. Capital T is the bit this duration. Okay, mostly in some book they will mention like TB also. TB, okay, the duration. Okay, capital X of TB minus T. Then how to draw the function? Say you are given with x of t 0 to t, then from that you first find out x of minus t. This is x of t, then x of minus t will become like this, say minus t. Then what is x of capital T minus t? What is x of capital T minus t? Then again in this case it will become like this only. Okay, but if it is a triangular signal, it would be somewhat good. You can observe the difference. Say I'm taking my x of t something like a triangular signal. Then once if we do the x of minus t, it comes like this. Then if you do this operation x of capital T minus t, again from the basics of signal system, so you have to shift this by the factor of t to the right side. So it will come like this. So now you want to do the convolution for figure 1 and then figure 3. Do the convolution with the figure 1 and then figure 3. So once if you do the convolution, then we will get the proper response. We will get the proper response at the output side. We can get the proper response at the output side. That is the idea of the matched filter. So, and also where we have to take the sampling, so that definitely that y of t will be spreading from 0 to 2t. Why? Because each signal is having 0 to t. Okay, so definitely the output will spread from 0 to 2t. Now at which point you have to say take samples to decide about your values. Sampling has to be taken at the middle. So now take the sample at the middle. Take the sample at middle at t is equal to t, then easily you can recover back your original signal. That is the idea of the matched filter. And then what is the signal to noise ratio? What is the signal to noise ratio here? In this case, signal to noise ratio of matched filter is always less than or equal to 2 EB by N naught. You know EB means bit energy, N naught is the power spectral density. At any point of time, signal to noise ratio in the matched filter is 2 EB divided by N naught. Then what is the maximum signal to noise ratio? What is the maximum signal to noise ratio in case of matched filter? That is 2 EB by N naught. Maximum signal to noise ratio in case of matched filter is 2 EB by N naught. So mostly in the exam, we'll be getting question based on this. What is the maximum signal to noise ratio for the matched filter? That is 2 EB by N naught.